And so I'm very honored to present today this talk that started this thinking over 20 years ago. And I'm really glad I'm here because it means somehow it made it. And you probably will see many companies developing stuff like this, but 25 years ago, all this was science fiction and it wasn't very easy. So my talk will introduce to you what is event-based vision. And to be very clear, I'll try to give you insights and help you, and anyone who has a question, please reach out. So to start with, there's a big confusion out there about neuromorphic. Now, neuromorphic is too wide. It's as if you say, I play ball games. Which one? So I play event-based, and I'm part of neuromorphic, which means part of the people who are trying to copy neurons to do something meaningful out of them. And I'll hope you convince you that this is the future, and there are many hints that this is definitely the future. So let us start. So why is this a future? So to understand that this is the future, let us understand the present and the past. And I think this is a refresher. 50s, perceptron, 59, Nobel Prize explaining how visual cortex worked with Hubel and Wiesel. First ever digitized image. We can keep going. Into the 60s, Larry Roberts, the father of computer vision, did lots of filtering. Then this is another milestone, first MIT summer project. And then the real thing, 69 with Rosenfeld, who is really the father of computer vision. Most people who develop things came up from his lab. And of course, Marr, that led all this idea we have of how vision should be performed with, hierarchical ways and features and how all that. That's a wonderful book to read even today. And of course, the 90s, that were characterized by geometry and everything that is well summarized in this book by Wisserman and Hartley. Then the 2000, where everybody was looking for features and trying to make sense of them, it was successful. The SIFT, the SURF, you all know that. And then suddenly, the 2000 and the advent of machine learning, as Jeff said, it's not some sorts of God. You give something to it and it's going to respond to you. And of course, now the big game of putting machine learning all over the place to reaching complexity where you need almost $20 million or $40 million to train GPT-3. So what's next, right? That's a fair question to ask.